Je suis belge, mais je ne parle pas français, juste un peu. Donc, euh, je vais faire les slides en anglais. And I will talk in English. So, this talk is about caching with PSRs. I was at PHP Tour last year and the year before as well, but this is my first time in Montpellier, and I really like it. You can tweet about this talk with hashtag PHP Tour, and you can use my ridiculously long Twitter handle if you like. So my name is Hannes. I like to do sports. I like to do swimming, cycling, and running. I haven't done a triathlon yet, so don't ask me about that. I'm not gonna talk too much about myself, so I'm gonna dive right into the actual topic of this talk. So caching with PSRs. We've been doing caching a long time on all different layers of our application. But this talk is going to be about caching in a modern way with modern interfaces. Can I have the handheld mic anyway? It's gonna be a bit easier than the floppy mic. All right, this is better. So, caching in a modern way or with modern interfaces in PHP, like the recommended way of doing caching in 2018. This talk is divided into different chapters. I'm going to give an introduction first on what is caching, and then I'm going to talk about how we did caching before PSRs. And then obviously I'm going to introduce two different PSRs, and I'm going to talk about how to move from the old way to the new way and how they work and what the differences are between PSR 6 and PSR 16 and why they were actually introduced, why there are two PSRs. That's going to be the most important part. So introduction, what is caching? I think most of you have done caching in their applications. Number one reason is to speed up your app. Some apps might be a little bit slow because of some slow processes. Could be a slow query, or could be a slow HTTP call or slow PDF generation, something. We want to actually have some kind of process to memorize a state or memorize a result if the input is the same and the output is the same. Well, if the output is the same according to the input, we can actually cache it. So we do something that is slow, and then we remember the result. That's how we cache. Rule number one of caching, if your caching layer fails, your app should still work. So should not cause an app failure. If your caching layer is disabled, your app should still work. This is very true if you have a local development environment. Your caching is probably disabled, but your app should still work. If your Redis or Memcache is not accessible, your app should still work. We can do this. We can do caching for any kind of slow, long polling, whatever task. For example, a slow HTTP request to some server on the other side of the world. If we do this a lot, we might lose a lot of time, and if the input is the same and the output is the same, we can cache that. For example, a slow database call. We can cache a slow aggregation call to a database which has the same output for the same input. Or when we process an image or a zip file or a PDF. Rule number one, I'm gonna repeat this every other slide. Your app should not fail if your caching layer fails. Another example of caching is, for example, geocoding. We can cache that because for the same IP address, we will get the same geocode result. So we get the same location for the same IP address. So the process is like this. We check the cache. Did we geocode this before? If not, geocode it right now, and then store the result. The next time when we want to do the same thing, if we want to do the same geocoding for the same IP address, we check the cache, we get the result, it's there, it's fine, and then we use the result without actually geocoding it, because geocoding might be a little bit slow. Again, your app should not fail when your caching is disabled or when your caching fails. This works on different layers. It works on the user agent level, so we might cache CSS files, JavaScript files on the user agent level, which means your browser. It works on the web server side, so your Varnish or Nginx might cache some static files. This also works on your application layer, which is what we will be talking about today in PHP. So your application layer should cache some stuff, or could benefit from caching. Again, your app should not fail. Or upcache, that's another level of caching. So PHP is a double iteration of generating bytecode. So we first generate like the opcode, and then from the opcode we generate the bytecode. But if the source code is the same, we can actually reuse the same opcode compiled opcode. So that's another level of caching. Again, your app should not fail when your caching fails. And then there's a bunch of other topics we can talk about, but I'm not gonna go too deep into this. There's cache busting, which basically means invalidating cache before the TTL is actually reached. The TTL is the time to live. So you can define a time to live for a cache value to be true. Generally, well, there's different strategies, but I'm not going to dive too deep into that. You can set a long TTL and just do cache busting to invalidate cache and regenerate it, or regenerate the value. And then there's also a thing called warming up cache. So you have some kind of a cron job or background process that basically replaces values every now and then, so that the front end or the user never experiences the slow process. So the second chapter is caching prior to PSRs. Prior to PSRs, everyone did caching. Libraries did caching, frameworks did caching, and then there were pure caching libraries that did caching. So libraries would, for example, a geocoding library would have their own caching layer or their cache decorator or something, and then they would have their own set of backends that they would provide. They would provide, for example, Redis, but not Memcache, and that would pose a problem. If there's no interface, you cannot say, for example, you have an application and your framework has a Memcache setup, but you want to use a geocoding library that has some caching backends, but they don't provide Memcache, then you would have to provide your own implementation or adapt to the interface of the geocoding library. That poses a problem. Well, if you like to write adapters, then it's fine. Adapters everywhere. Adapters between frameworks, adapters between libraries, adapters between packages or libraries and caching layers and caching packages. There would be a ton of adapters, and you would want to basically have one backend, for example, Redis or Memcache, and store everything in there. Because if you don't do that, if you would use whatever caching backend that the library or the framework or the caching library provides, then you would have different backends, and your ops people will not love you for that. If you would just randomly distribute some caching values into Redis and Memcache and file system and S3, if you're into that, no one will love you for that because your infrastructure gets way more complicated. So that was a big downside, and that was one of the big reasons to introduce a PSR. That was one of the big reasons to introduce some kind of PSR or some interoperability layer in between libraries and frameworks, because everyone would have their own set of supported backends, and everyone would have their own set of adapters in between all of that, and everyone would have to implement their own adapter between the libraries and the frameworks they would use. Because they would use a framework config to set up their caching backends, but then they would have to write adapters to use the geocoding library in this framework or something. And that's a big burden. So say hello to PSR 6. PSR 6 got finalized and accepted by the PHP FIG in December 2015. So it only started getting some traction into 2016. And the way PSR 6 is actually works is in some kind of repository and entity pattern. So there is an item pool, which is basically the repository, and that item pool keeps track of all the items. And all the items are value objects with a cache key and a cache value and a TTL. So the item pool keeps track of all the entities and does the actual connection with the backend. So the item pool knows which items are stored in the backend, which items should be destroyed, which items should be saved next time. So that would keep the connection, and it would keep track of all the items out there. So if you would ask the item pool for the same item twice with the getItem method, with the same key twice, it would give you the same value object. It's a bit like Doctrine with entities. But these are just interfaces. There's a cache item pool interface, which is a super long name, and then there's the cache item interface. And cache libraries are supposed to implement these interfaces and implement a caching layer this way. So you get an item from the pool, and then you can get the key and get the value. This will actually return the value of the stored item. And then you can also do other methods like has item on the item pool. I should actually show the code, but this is not my laptop. I have a confession to make. I left my laptop at the airport security, so I can't really show the code right now. So the cache, I would normally dive into the, maybe I can do this. Let's just go to GitHub. Yes, it is very risky. GitHub. Where am I? Am I doing good? /php-fig. Woohoo! Internet. Right, repositories. Can we search? No, this is pinned. This is search. So cache. No. Is this cache? There it is. Cool. Let's actually take a look at the interfaces. That is much easier to see. Yes, I can. So I'm going to the cache item pool interface. It's going to be pretty hard to browse this code. But if you do Command F or do public function, we can actually tap through the different methods. This is why a handheld mic is not useful. So there's different methods. Enter, right? Okay. So there's different methods. There's getItem, which returns one item. I showed this on the slide. There's getItems, which is actually a batch operation. You can give it an array of keys, and it will give you. This is kind of tricky. This will give you an associative array with the keys as a key of the associative array with the items as the values. And there's also a hasItem will return a boolean. It either has the item or not. It also has clear to basically truncate or clear or delete all items. There's delete item to delete just one item by the key. There's delete items, and it will return a boolean whether that's it's exceeded or not. It takes an array of keys to delete. The next method is save, all the way in the bottom. I think I can scroll a little bit more. Save basically saves one item. So you can give it an item that you retrieved first, and then you can delete it. The next one is save deferred. This is some kind of, it's batch, but it's also like deferring something. Like I want to save this, but not right now. you have the connection with the backend, so you know what the optimal size is of items to store to the backend. So you can either wait 25 items long or 100 items and then batch save that. And then there's also commit, which basically makes sure that all these items are stored whenever you end this request or something. I think there's also a destruct. This is supposed to be called on destruct. So if you end the call, or if you destruct or garbage collect this item, it should also commit all items. If you garbage collect this item pool, I should say, then you should also commit all the deferred items. Now, if we go back, then we can take a look at the cache item interface. Right, the cache item interface is pretty easy. Public function. There's a get key, which returns the key. There's get, which returns the value. Zoom. All right. There's a get key, which returns the key. This is basically unchangeable. So if you have an item, an instantiated item object, the key can never change, but the value can. So it's not really immutable. This is to make sure that there's only one item in your entire application with this key. And then there's get, which returns the value. There's isHit, which returns, is this actually stored on the backend or not? So if you ask the cache item pool, give me a couple of items, some of those items might not be present on the backend. So it might return isHit false. So you have to check that first. So you first check if the item actually exists. You first get the item from the item pool, and then the isHit might return false. So you have to do two method calls. And then there's set, which sets the value and expires at or expires after. There's two ways to set the TTL. So you can set the expires at to give it a datetime or a timestamp, I think. And then there's expires after, which gives you which should take TTL. So it gives you a couple of seconds or minutes. Or a datetime interval. That's pretty cool. All right, let's switch back to the slides. Woohoo. So the item is an entity. It's not immutable, but the key is fixed. This is to make sure that each and every single item has an identity and it only exists once in your application. So you should never create your own item objects. If you want to store something, you first get the item from the item pool, check if it's hit or not, and then set the value and store it. Set the value, set the TTL, and then tell the pool to save it. The pool has support for multi-actions. I showed you this in the source code. You can get multiple items, or you can save multiple items, or you can delete multiple items. So you do save deferred, and call that multiple times with multiple items, and the pool itself will decide. Oh well, I will do an intermediary save, if that's necessary, and then in the end you will do a commit to make sure that all items are saved. So it's a repository entity model, and the reason why it's a repository entity model, it might seem a bit over complex, but it's actually to allow some extensions, and there's some applications or some caching libraries that already implement some of those extensions. So you can basically add more methods to the pool, the cache item pool, to add more features to this caching implementation. There's also a couple of characters which are excluded from being used. You cannot use these, and that's actually to reserve future extensions to this spec. So there's a couple of features you can add to this. There's a stampede protection, and I got this cool timeline, and I hope it works. Okay, it works. This timeline should show you how stampede protection works, or why it should you should add that to your caching layer. So this is a timeline, and the orange bar is the timeline, and it progresses like this. Wait. So the light part is how far we are in time. There's an incoming request, and it's pretty slow, so it's gonna do a long-running process, or a slow database call, for example. And then it's going to store the result at the end of that slow process. It's going to store the result, and it's going to set a TTL. But the TTL is kind of split in two parts. And more requests are going to come in, and they're going to use the same value from the cache store. And then when the TTL is almost done, there's going to be just one request, which is going to recalculate the value. And the other incoming requests, this one, and this one, and this one, and this one, and this one, are still going to use a valid value of the cache item. But just one single request, because you might have 10,000 connections at the same time, is going to recalculate it. If you don't do this, you risk that in this small time frame, 10,000 requests are going to do the exact same calculation. So you only want one user to experience the slow running process. So all incoming requests are still going to use the value which is still valid until here. And then the value is going to update it, and it's going to have a TTL again. And then when the traffic slows down, your value might expire, but the first one is going to recalculate the value, which might take a long time to calculate. But that's okay, because your traffic has actually died down, and the risk of having 10,000 incoming requests at the same time is pretty low by then. You can also do this by setting some kind of timer or a cron job to recalculate the value in the background. Another feature you can add to a caching layer is tagging. I don't know if this is, with the light, it's pretty hard to read, right? This orange part. Is it readable? Okay. So there's a library called cache/taggable cache. And it allows to add tags to cache items. So a cache item might get a tag, for example, category 1. And then you can tell the cache item pool to invalidate all values or all items, basically to delete all items which are tagged category 1. You can add multiple, because this is an array, you can add multiple tags to an item, or you can add the same category to multiple items as well. And then there's hierarchical, hierarchical cache, and it's implemented by the library cache/hierarchical cache, and that allows you to set some kind of key which has an hierarchical, multiple levels. So you can say, you can ask a pool, or you can set an item with a key, for example, users 4711, and then you can add multiple levels after that, and say, I want to invalidate everything that starts with users pipe symbol 4711. So users pipe symbol 4711, followers, users pipe symbol 4711, pipe symbol likes, and everything that's behind that, or that's under that hierarchical key, you can invalidate that in one go. This basically uses the same cache, cache as well, to remember all the items that are below this key. So it's kind of recursive. So let's get a little bit more practical. This has been pretty theoretical and high level. So who uses it, and how can I start using PSR6? If you go to packages.org and we type in PSR/cache-implementation, you will see that this is a virtual package. So the actual code or the interfaces are in PSR/cache. But if you type in this PSR/cache implementation, you see that it's a virtual package. There's no installs or stars here. If you click on this, you will see that packages will route you to a page called providers. And this shows you all the packages that provide an implementation of these interfaces in the PSR/cache library. So you can see that there's a bunch of them, and the most famous one is Symfony/Symfony and Symfony/cache, because Symfony/Symfony includes Symfony/cache. There's, I think since PHP, Symfony 3.0, it implements the PSR6 interface, or it provides an adapter inside this package. If you click on one of them, this one is cache/file system adapter. This basically allows you to cache on the local file system, or it actually uses fly system, leak/fly system, to cache something anywhere you like. There's no real benefit of storing something in cache on S3, but anyway. You can see that in the provides block of the composer.json file, it says it provides an implementation of PSR/cache implementation. So this allows us to look up all the implementations of PSR6. You can go to packages.org, type in PSR/cache-implementation, and you can find all packages that provide it. If you want to implement your own implementation of PSR6, you don't have to write the tests yourself. You can use this package called cache/integration tests, and this package provides all the integration tests you need. You just need to require this. I think it's require dev as well. You just put this in require dev and create one cache pool test. This is a PHP unit test. You need to extend this and then implement this one method, create cache pool. You new up your own cache pool with your own backend if you want. And then this will run all the tests. That's pretty neat. I've done this before. It's super easy. And then there's a couple of packages that already provide you implementations. There's taggable cache, namespaced cache, hierarchical cache. There's chain adapter, which is pretty neat. If you have this basically chains different cache implementations. So if you have a fast cache, which is limited in space, and a slow cache, which has a lot of space, you can actually chain this to be some kind of a first level, second level cache. So you can have different levels, and then update the local level or the faster level with the slower cache, which has more space. It's basically like L1, L2, L3 level caching on your computer or your CPU if you're into that. And then there's array adapter, which is basically in memory. There's void adapter, which basically says, it basically remembers nothing. It's basically a dumb adapter. You can use this if you want to test your application locally, you might want to use void adapter, because this will just forget everything. But remember rule number 1, if your caching fails, your app should still work. So this void adapter is super useful in the local environment. And then there's prefix adapter if you want to separate parts of your applications to be part of your application cache to be stored under a different prefix. And these are all decorators, the last two. No, the prefix adapter, the namespace adapter, and the taggable cache adapter are all decorators. So you can just wrap existing ones in that. So how to upgrade from the old way, the framework and the different the different libraries using different implementations, up to PSR6. Well, for libraries, it's kind of a breaking change. So you might want to, you need to wait to the next major version to introduce PSR6 in your library. So yeah, wait till the next major version to make this breaking change, and then introduce like a PSR6 enabled decorator or something. For frameworks, you can already start using this. Frameworks are a bit slower in making new releasing a new major version, because there's so many users. Well, or you don't want to just introduce a new major version because of a new caching layer. But you can start using adapters. There's adapters for, well, Symfony 3.0 came out with PSR6 support. Laravel has adapters. Cake PHP has adapters. There's Symfony slash cache, and there's cache slash Illuminate adapter, which is a Laravel, the adapter for Laravel. So you can start using your existing Laravel configuration. But if you want to start using PSR6 in your Laravel application, you can still use your already configured cache layer and start using the PSR6 interfaces. So how is the adoption? Sadly, it's pretty low. If you go to packages.org/packages/psr/cache-implementation/dependent, it's a pretty long URL, but it basically tells you which libraries depend on this implementation. You can see that there's only 9 libraries out there that depend on this. And basically, the PSR6 doctrine bridge is one of them. So the adoption is pretty low. Some people say it's because it's too complicated. There's the repository entity thing, and it should be just get something from the cache and store something in the cache, and not having different items and objects and interfaces. Some say it's too difficult. So 1 year after introducing PSR6, some people came together and they said, well, let's make something simpler. So they introduced PSR16, which is also called Simple Cache. So the PHP fig is kind of distributed between people that are preferring PSR6 and people that are preferring PSR16. And it's finalized and accepted exactly 1 year after the old one. In December 2016, this was finalized and accepted and as a official PSR standard recommendation. It's not a standard, it's a recommendation. And it only has one simple interface, which is called PSR Simple Cache Interface. And it has, I think, 2 methods. Yeah, set and get, and that's it. No, it has more methods, sorry. So it has a set, so you can set something, and then you can get something. The problem with this is it doesn't have any way of telling is something actually stored or not. You can store null, and then you would not know if you stored null or it's just not available in the cache store. But you can get around that by storing some kind of value object or some object that says this is not available. Some kind of object. So you get that object back and you can do instance of. Then you can check, well, I actually stored that this is not available. So it's kind of a negative cache. You know, when DNS cannot resolve something, when something is when something is not an existing names, like a DNS name, you have a negative cache as well. So if you register a name after trying to resolve something, you will still get the non-resolved result for quite some time until the negative cache has expired. So a negative cache is also something to think about. Did my slides just... When did this happen? 5 minutes ago? Yeah. 2 seconds ago? All right, we're there. Cool. So you can set... It's gone again? I won't touch it. Right. So there's a couple of methods. You can get multiple, set multiple, and delete multiple, so you can have batching as well. But there's no deferring. There's no saying, oh, well, I want to get the item pool to define the optimal batch size. So you have to do this yourself. And there's no way of differentiating a null value between something that is not in the cache or something that is stored as null. Sorry? There is a has method? Okay, good. I should adjust this then. So, all right. It also allows for future extensions thanks to the reservation of these exact same characters. So, I'm running out of time here, but that's fine. Right, 5 minutes. See, my French is not that bad. So, again, the practical part of this is who uses it and how can I use it. It's basically the same. We can go to packages.org and find PSR/simple cache implementation and see who provides it. Again, Symfony Cache is up there. Symfony Cache basically provides you with PSR6 and PSR16, whichever you prefer. You can also use this same cache/integration test package to make your own implementation and check that according to the spec. If your implementation is actually up to the spec. The upgrade path is basically the same as well, so you can use adapters for now between your framework and your PSR16 libraries that use PSR16, and the adoption is pretty poor, to be honest. Last time I took a screenshot, this was even 0, so that's better than nothing. It's pretty sad, but anyway, you can start using, well, basically applications are not in here, so a lot of people use this in their applications, but there's not a lot of libraries that depend on this. A lot of libraries might depend on an actual implementation instead of on the virtual package though. So I didn't look that up, but. And then there's, obviously there's PSR6, and it's like there's too many standards problem, so we create another standard, and then in the end we end up with 14 standards instead of 13. This is the same thing. We had too many adapters, and now we just have one more. There's an adapter or a bridge between PSR6 and PSR16. So yeah, you can, if you already adopted PSR6 before PSR16 was out, you can start using PSR16 simple cache by wrapping your PSR6 caching layer or caching item pool with a bridge adapter, or I think it's a decorator. So in Laravel, you could do this. I would not recommend this. Create a Laravel configured cache item, which is a custom thing. You can wrap that with a PSR6 adapter, and you can wrap that with a PSR16 adapter. But that's pretty nonsense. Don't do that. So to recap, because I'm running out of time here, I introduced caching and all a couple of different aspects around caching. What was rule number 1? If your caching layer fails, your app should not fail. And then I talked about too many adapters between all the frameworks and all the libraries and all the caching libraries. I introduced PSR6, and PSR16 is the simple way. Thank you. We may have time for 1 or 2 questions.
Yes,
you can even pose them in French. I can understand French. There's no coffee break before the first question. Okay.
If your caching layer fails, is it okay for your app to fail?
No. No.
Thank you. And what do you suggest to use between PSR6 and PSR16 based on your experience?
Oh, PSR16 is easy. It's simple.
Okay, thank you.
One more question?
Hi, and thank you. I'd like to know why the deferred was removed in PSR16, the deferred pool, and why in the PSR6 there is no possibility to access to the deferred pool before committed.
So the question was,
thank you.
Why is there no deferring in PSR16? Because some said there were too many features in PSR6, so they cut some features to make it possible to have one simple interface. To do the deferring, it's just not part of. When you create an interface for whatever you're going to implement, you want to make it as simple as possible. Like, what is the ultimate, the core, the essence of this interface? And then you can extend this interface with with more features. So for some implementations, it might not make sense to have a deferring. For example, writing to file. I don't know if that makes sense to defer something to write to file. It's pretty quick anyway, or you can open a stream, whatever. So basically, when defining an interface, you want to get down to the essence of what this interface should do, and then you can extend that with whatever features you want to add on top of that. I think that's one of the reasons. I'm not part of the committee, or I'm not one of the authors of the spec, so I can't really say the exact reason. But there's a Google group, and you can dive deep into the discussions and find out yourself if you want to, if you're into that. I hope that answers your question. Okay.
Merci beaucoup. Maintenant, vous avez 25 minutes de pause.